Hi, and welcome to another Hopper display driver video. Um, about adding display drivers. I'll file it under microcontrollers. Anyway, you could look at some of the other videos linked to this or the channel to see what this is all about. If you're new to Hopper, Hopper's a alternative programming environment to say Arduino or MicroPython. Anyway, ever had some of those things you've had lying around that you've never used that you might have got in the really early days of when you were first playing with Arduino, like one of these little matrices or one of these little 7-segment displays? Well, I did. So I had one of these matrices lying around. So I thought it's a good thing to write a driver for, because it's a good example of the simplest possible driver. And I don't need to do much more than just be able to draw a pixel, because once I can draw a pixel, it'll dovetail into the rest of the driver system, and it'll be able to do this sort of thing: draw rectangles and text and lines and invert things. And anyway, so all I need to do is get to draw a pixel, is what I figured. So that's what I did here. So the driver, to use the driver, you simply say which device you're on, and you include the driver like that. And then in the main part of your program, you set it up by saying which pins it's on. And it's obvious from here I'm on pins 1, 2, and 3 right at the top. This, by the way, is a Waveshare Raspberry Pi Pico clone. Pin-wise equivalent, same ratio, etc. So you can use this as a direct drop-in replacement from Waveshare. But it's got a USB-C connector, which I really prefer. That's why I prefer it over my Pi Pico. Anyway, let's get on with it. So if I build that, F7, it's compiled it, and then press F5 to get into the debugger, and then I'll start stepping. F10, set up my pins, initialize the display, and then make it black. It's already black. Step in there and draw a pixel, and we've got a pixel in the top left corner, and we're going to draw another pixel. Let's go down here and put a breakpoint, and then draw all the pixels. So we hit our breakpoint, and now we're going to draw some rectangles, and then this fill rectangle is going to invert them. It's going to draw by inverting what's already there, so it has to read the screen. So it inverts that, and then it goes into the center and inverts another square, and then into the center by 1, and then inverts the center again, and then inverts again. And then let's just get rid of that selection. Draw lines is drawing, it's the same as that other test, it's just drawing lots of lines. And to make this be visible at all, I had to put a delay in of 50 milliseconds between every single line. Otherwise, it's just instant. It's it's only drawing 64 pixels, so it's very, very quick if you don't wait for the delay. And then I've written a little utility to draw some text. So that's what that looks like. And again, I've got delays between each character, otherwise it'd be way too quick. So I'm delaying between each character, 250 milliseconds between each character. So, and then if I can run it outside the debugger, if I just run it like that, there we go. Okay, now more about driver writing. How did this driver get written? It was all written in Hopper source code, so let's reload, and let's go to this breakpoint, and F5 to there. If I step into it, it's getting the font data because I included a font. So in my program, I included a font here, so now it knows it has a font. So yeah, you can double-click over here to travel around, double-click over there, double-click on the stack, and you can travel around your project that way. And then it calls, so this is inside display, which is a generic unit for all displays of all kinds, TFT, LCDs, OLED displays. And now it's calling into my driver here. So now it's in my display driver, which is this LED matrix driver. And this is what the setup code looks like, and it's all written in Hopper. So set the width and height, set the pins, set them some good default values, and then set some initial settings for initializing this matrix. And if you succeed, now we've succeeded with initializing the driver. So, and if I step into the pixel, let's do that one. So it'll go to the generic set pixel that's in regular display, which will then call into this current display driver set pixel. And this is the code that's busy populating that buffer with pixels. And then there'll be another somewhere else. There'll be an update thing here that transfers the pixels to the device. Anyway, this entire driver was written this afternoon and just all in Hopper. And it's, what, 150 lines long. And it's pretty verbose with the spacing to try and make it readable. So it's not very much code to write a driver. And I intend to expand this driver. So for now, I've hard-coded certain things, like I've hard-coded the width and height to 8, because I know that I'll get back to it. There'll be a time when we want to do more. So when we want to do, like Adafruit has some products which are going to be kind of cool to use as display drivers. I've already shown you the Pimeroni one in the intro, and then there's this one from Waveshare as well. And this might be a NeoPixel chain, a NeoPixel string, but still it'll be implemented in a very similar way to the matrix drivers. Anyhow, one more driver for one more class of display units. Been wanting to actually do something with that device for years now. I've owned it for a very long time. Let's get that going, and then I'll fade out. Anyway, thank you for watching, and I look forward to your feedbacks. Go and have a look at some of the other playlists, like I think I'll link here to the Hopper language playlist, and you can learn a little bit more about Hopper if you're interested. Thank you.